All right, we're going to get into this. We got week 7 summary for year 1 doubles. So firstly, we just have these topics. You can read this if you want. Just some obviously the first part's simple, next part is not so simple. Stuff about the assignment, read if you want. Just read if you want, just to get through it quickly so we can move on to doing the actual assignments. So let me get it up now. All right, let's go from the start. Yeah, I just need to close this, sorry. All right, there'll be a few things in here you might just have to ignore that I was just messing around on the assignment. Anyway, first question, we got some graph sketches, just some simple reciprocal graph. Then solving this, you actually have to say that x is less than 0, because otherwise that just doesn't work if x is less than 0. We have these functions here, we're just doing composite functions. You substitute the thing on the right first, and then substitute that into the thing on the left. Part B, again, substitute the thing on the right, so this entire function into the thing on the left. This notation is just the same thing. The colon just means f of x, and the arrow just means equals. So you do all the simplification, set it equal to x, because that's what it tells you to do. I just drew this out. You see that it intersects twice, and then you do a positive 1 and a negative 1, and these are the right answers. Question 3, we've got a lot of graph sketching. I'm just going to kind of show the graphs. It's just a lot of transformations, obviously. Part B, if I skip all this stuff, all right, what have I done? Go down. This is just a bunch of stuff that I have to do. All right, so here it is. So part B, we have, this is just a lot of log equations, so you can either use base answer power or just use, take the log of both sides, it doesn't matter. So this one, I use base answer power. Next one, just take the log of both sides, or use base answer power like I did. Same with this one, I think, yep. Number 4, you just combine the logs and say that, here I raised them both to the power of 10, because if you have like something to the power of log base something, and they're the same, then you can just cancel the log out. So you just get 5x equals 10 to the 7, and that's the answer. Next question, it's a hidden quadratic, because 4 to the 2x is just 4 to the x squared, and 4 to the x plus 1 is just 4 times 4 to the x. For the next part, you just, it just basically gives it to you already. You just add log base 5 2x to both sides, and then you have this. You can just cancel the logs out. With the next question, you just have to turn the 2 into log base 525 and then combine the logs, and you can do the same thing and just rearrange. Next question, this question tripped me up a bit, it was quite annoying. It's quite easy when you get used to it though. So we know that the radius is the same, and the arc length will be different because they're changing the angle. We know that the area of the triangle will be half AB sine C, so just half times x times sine of pi over 3, and that will equal a half r squared theta. Yeah. Oh, sorry. And they will cancel out eventually, and you just get this ratio, and say that this is a 15% increase because 1 to 3 over root 3 over 2. Next question, we have this model here. Just set this up. It's a compound interest. It's kind of something from GCSE, but kind of just expanded upon. You set it equal to whatever it wants you to set it equal to, and then solve with logs. And then you round up because it's a year. Part B, it's just 0.75 to the t, and then you use an inequality, and you just say that you solve the equation. Here I logged both sides, and say that it will be in the 8th year because you round up again. For the next question, What have I done here? I did question 7 first. All right, we'll go to question 7 first. So you're just doing the first 3 terms in ascending powers of x, so you just use just binomial expansion, really. It's finite, so you don't have to do anything annoying. And you just do kind of just binomial expansion. I don't know how, if I can sugarcoat it. So you just expand everything, cancel everything with the calculator, and then to find the approximation, you just set the thing inside the bracket equal to the thing you're trying to approximate and solve for x, and then that's what you substitute in. Now we're going to question 6. These are just some simple integrals. You don't really have to worry about this. You just do the integral and then substitute. I haven't shown substituting the bounds. Well, I've showed substituting the bounds here, but not in these two because it's just easy. Now we go into question 8. We have this question here. You just take the log and you just say that when you have log base 3 of 3x squared, if you put log base 3 of both sides, you can move the 3. You can move the x squared over, and you can also separate the 3's. So yeah, and then you just separate the logs out. Because you have 2 things multiplied inside a log, you can express that as 2 separate logs, and then log base 3 of 3 is just 1, so that will cancel. Next question, you turn the 1 into, well, you already know that that's 3x squared, so you just set that to 3x squared, and then you have an equation with just log base 3 of something equals log base 3 of something, and you can cancel the logs and then solve the quadratic. Next, this is the definition of an integral, so you just turn it into an integral and then do the integral. It's not rocket science. Next question is just, so this is just, A is just solving this simple equation. Use base answer power again. Base being x, answer is 2, and then 64 is the power, the power's 2. And it can't be negative because you can't put a negative value into a log. And for part B, they are asking you to just, they're asking you to just simplify the logs again. So you move the 2 over here, you turn the 3 into a log, which is log base 3 of 8, and the 8 will combine. I kind of skipped a few steps here, but you move the 2 to the power, and then you turn 3 into log base 2 of 8, and then you multiply, and then you solve. It turns into a quadratic. Next 2 questions, we just got some tricks. So you always have to do the bounds when you have something inside the bracket like this. You have to change the interval, and then you just solve. You could use a substitution, but it doesn't really matter. You could just write it as x plus 30. Next question, we have the same thing. You just do the bounds and do that. You get final solution. There's a lot of solutions because it's a tight graph. So you'll just divide everything by 2. Same, just do the exact same thing for the next one. There's only one solution here because it's a wide graph. Next question, we got some curves. It's just function transformation. So for the you have to sketch the new thing as well. So you just apply the transformation to all the coordinates. So you're doing the opposite of what's ever in the bracket for the x, and then what's outside the bracket you do to y. And I've just sketched all these coordinates. So 2x will make the graph tighter, then the 3 on the outside will make it taller, and the plus 3 will just move it up. Next few questions, this is just a very complicated way of saying set so the big graph is less than the small graph. So you just do that. You just solve the quadratic inequalities. It's just kind of like GCSE. Same thing here. Same with the x is less than 0 thing here. And same thing here. You just set them less than the other thing, and you solve. It's just kind of, they use the weird wording here, the set of values where it's below the line, but it's kind of just, you set them equal to each other basically. Alright, this question was kind of like a weird problem-solving-y thing. So firstly, what I tried to do is I tried to say that the area of this would be, it would be 4 times, because these are just rotated versions of the curve. So if you integrate this, 4 times, it will give you 4 of these areas. But what that will do is it will give you the area of the curved bits on the outside, but it will give you twice the amount of area you need in the middle. It will give you 2 of these squares. So I just found the area of the square and took away 1 of the squares, because you get, when you integrate this 4 times, if you integrate this curve, it goes like down hit to the axis. So if you only did the top and the bottom curve, then it would just give you that area. But because you're doing it to all 4 curves, you're going to get 2 times the area in the middle. So you just subtract 1 of the squares, so you can get all 4 curves plus the square. And I just firstly set it equal to y equals x, because that's where it says the line's y equals x. So that's how you find a and c, by setting it to x and negative x. Find the points of intersection, and then integrate, use those as the bounds for the integration, and then subtract a square, which gives you this answer. Next question. These are like the only really 2 difficult questions or they're the most difficult questions in the section by far. So what I did here is I just said that this first part was pretty easy actually. You just expand, and yeah, you literally just expand it. And when you do cos sec or sec cos, it will just cancel, because it's 1 over cos times cos is just 1. So it's 2 plus cos squared plus sec squared, and then sec squared is just 1 plus tan squared. So you can just do that. The next part is a bit more difficult. You know that cos squared plus tan squared is just cos plus sec squared minus 3, because of this thing you proved earlier. So you can turn that into this, then add 3 to both sides, expand, and then you have a hidden quadratic here with cos squareds, and then you solve, do whatever, and then you set the u back to cos squared, and then rearrange, and then solve for all the values. Right, section B, we're going to this is all applied, I think. So these are just the diagrams. I'm not going to explain all of them. These are all just, it didn't make it clear if you were supposed to do the values or like what everything was. I don't really know, but these are all the diagrams. I'm not sure if they're 100% right, because they're not in the answer thing, so don't take them fully, but they're pretty accurate probably. Next question, we have velocity time graph. It's pretty simple stuff. Then we have some SUVAT, where you're just finding the maximum height, which is where you're finding the maximum height, yeah. Where, because the total displacement will be 0, and what I've done is basically said that the Jesus, what am I doing? The time will be half the time it takes to get to the top, which basically I've just used this equation to find this here, because we know the displacement, and then we can use that to find the maximum height and the speed. Oh, sorry, no, I think I've done part, because it said, sorry, I completely ignore what I just said, sorry. It says the maximum height and the speed of projection. So what I did, I said that s equals 0 is when the ball comes back to the ground, because that means that's the vertical height of the ball. And we know that it's negative g because it's a vertical motion, and it's 4 seconds because it says in the question. And then you can use v squared equals u squared plus 2as to find that. You find u, and then you substitute that, then you know u, so then you can easily find s. Sorry about that. And I haven't done part C, oops. It's small because that means air resistance is negligible, I think, and stuff like that. Question 4, ignore all the stuff in black. Have I done the same? I think I did the same thing again. Yeah, I did question 4 before I think I just completely skipped question 3. All right, oops. It doesn't look that difficult. It's fine. It's all just horizontal and vertical motion. Next question, we just have some, like, it just gives you a cross diagram and tells you to resolve stuff on it. So you can just express this like this and then resolve. Make sure you're using like the R horizontal, R vertical, and then solve. It gives you, no, it just tells you there's no simultaneous equations. You just resolve and it gives you it. question 5, you have, this is a classic question where it's just like, it tells you, yeah, it just tells you to do all this stuff. It just tells you, it tells you like one distance, and then it tells you another distance, and then you have to do a simultaneous equation. So it tells you that in 10 seconds it's got 180 meters, and after 7 seconds it's at 24 meters per second. So you can use, but you know that the acceleration and the initial velocity is the same because it starts from the same point and it's a constant acceleration. So you can just do an equation with both of these and then solve simultaneously for acceleration and initial velocity. For this next part, they kind of just, I don't really know, they just kind of turned it into an inclined plane question. So you have to draw out all the stuff like friction, normal force. You know the acceleration is 3 from what you just calculated, and then you get the trig ratio. I used alpha, I think, instead of theta, but it doesn't matter. And then you can express this. You get all this stuff here, and you can set them equal to each other, and it will cancel out m, because it will cancel out m because you can set these equal to each other, as seen by working here, and you can find the coefficient of friction. All right, next question, we have this annoying question. It's quite, so you just express everything on the diagram. I can't explain everything on the diagram. You just do the mass result. That you'll see, that's the common thing with all the questions. You have the normal contact force, you have the angle, and you have the weight, and the resolved weight. And then you realize that 3g is just 6g sine 30, so we know, 3g is just 6g sine 30, and we can set them equal to each other, because when you're resolving parallel to the plane, going down is 6g sine 30, up is 49 cos theta, and it's standing still. It lies, it's not moving, so you can just set them equal to each other, solve for theta, and you get what it tells you on the plane. Now we're finding r, so you just resolve the other perpendicular to the plane. Simple stuff. Then it's changed now, so the force is different. I've redrawn it now, and I've re-resolved everything. And it acts in a vertical plane. So basically, it's literally just going through the ball. You can think of it like that. And you're finding the acceleration because it's now moving. And you know that the mass is 6, so you know you can do the resultant force parallel to the plane equals mass times acceleration. And you can do this cross diagram again and solve for the acceleration using F equals ma. Next question. This is an easy question. You just resolve, and then it gives you all the stuff. I'm not really going to go through it. Next, we have another really easy question. You just multiply. You know that the mass is the same on every planet, so you just do that. It's really easy. Next question. This question was kind of annoying. There probably is a better way to do this, but I just did this instead. So I split this the series up into 2 different series. And when you're doing this, sum of 1.5 up to 50, you just add 1.5 50 times, so just 50 times 1.5, which gives you that, which you just add, and then you can find sum of x being 76.4, and then you can find the mean with that. So you have the mean, and then for the standard deviation, you can just say that I expanded the x minus 1.5 squared, separate them into sums again, and you can do this here. You can 2.25 times 50, take that away from both sides, and then you know that sum x is just 76.4, so you can substitute that in, and you get sum x squared equals 116.75, and then now you have sum x squared and sum x and the mean, so you can just calculate the standard deviation. Next question, we got some more mechanics. This was kind of annoying. You had to find the yeah, you had to find the, you just had to draw a diagram first. This was easy, and because it's not inclined, it makes it a lot easier to draw a diagram. And you know that the resultant force is 4,200, so you know that F is just the forward force, FB is the backwards force. That equals 4,200 newtons. And you know that the forward force is 8 times the backwards force, so you can just substitute that into the equation and find the backwards force. Right, now this question was probably the hardest question on the assignment, in my opinion. So firstly you just do the trig ratio. This is simple, but you know that the particle is going from A to B. It's being fired up on the plane. But firstly, we can write out all the SUVAT stuff. So parallel to the plane. This is what makes it quite confusing, because you, instead of doing horizontal and vertical SUVAT, you do parallel to the plane and perpendicular to the plane. You see with the arrows I drew. So the parallel to the plane, you know it's 5 meters. No, sorry, not 5 meters. Sorry, that's just. Sorry, no, that's just S. And you know vertically, it's 0. So you don't know the distance, but vertically it's 0. Perpendicular to the plane, it's 0 because it hasn't moved up in regards to the way we've set out the vector notation. Then you know the initial velocity because you can just resolve, and you know the acceleration being 0 and negative g. And because we have this information about the vertical motion, we can find the time. We can use s equals ut plus half at squared to find the 2 time values. And because we get t equals 0, we know that this is right because we know that it's on the ground at t equals 0, and then it comes back to the ground at this time here. Alright, question 12, we have just find the mean and standard deviation, just put it in a calculator, and then you find just use interpolation. I'm not going to explain how to do the interpolation because it's just interpolation. You just you do the lower bound of the thing plus the class width times how far this percentile point is across the interval that you're doing it in. And then just do that calculation. Now this question was a bit weird. So you had to say that, so you can set this equation now where x2 plus x3 equals 170, but you have to say for one of the angles to be obtuse, x2 or x3 has to be either from 0 to 80 because then the other one must be obtuse, or from 90 to 170 because obviously that's obtuse. So you know there's an interval of 160 out of the 170 degrees that it could be where it is obtuse, which means it's just 160 over 170, or I did 1 minus 10 over 170, because it can't. The only time it's not obtuse is when one of the angles is in between 80 and 90, because then the other one would also be under 90, which means the probability is 16 over 17. Next question, you can put this in a Venn diagram. This took me a while because you have to do a lot of weird things for this. So firstly, I put this in the Venn diagram, and I wrote down all the stuff that it gives you. Then you can write this out on the multiplication formula, like this. And then you can also use the addition formula over here. So, and I said that because we have h, we have just h without the middle part, we can write this like this. And we know that p of h is just going to be 0.72 plus the middle, because we're not given the middle. This is just 0.72 as the haircut without the shave. So the total probability of haircut is just the thing that gives us plus the intersection, which means you can rearrange this to get p of s intersection h equals 0.18. This addition formula thing, which you could also use the addition formula to prove that p of h is 0.72 plus the intersection point, but it's easier to think of it with logic because you can just add the intersection and that will give you the total probability of the other haircut. Alright, next, this is just, you just stating the domains and the ranges. I'm not going to go at. The graphs are pretty interesting. The reason why hi of x is x it looks like this and not like the one before, even though they're both just y equals x, is because you're putting ln into a function, and you can't do ln of a negative number. Even though e and ln cancel out, you have to take into account that ln can't be negative. And then for this, you just put, so it would be e to the mod x plus 3. That would be the hgf of x, and then you set that equal to 20 and then solve. ln 20 is just a straight line, so you just look at it like that. Now we have the best question in the entire assignment, obviously the large data set question. Firstly, we're just finding n, we're given the sum. We can do the sum thing that I did earlier where you do -5 sum to n, like this. So the sum of 5 to n, there's also an n here, but I just haven't wrote it because it's not important. So it's just sum of t minus 5n equals 55. You know that t you know that the mean is the sum of t over n, so that means the mean times n is just the sum of t, which the mean is 10, and n being the thing we don't know. So we just substitute 10n and we get this equation, solve for n, you get 11. Convert 11 miles per hour into knots. Obviously, you should always be knowing that to convert to knots, you need to divide by 1.15. And then comparing them, you just say the data. With reference to the large data set, staying one limitation, well, obviously you should know that the large data set only covers data from May to October. That's very important. It has come up before. And explaining how she can improve data collection methods, use any other data set, literally any other one. Why would you use an Excel large data set? And then to improve her data processing, you just consider other averages. Right. Thanks for watching. Hope this helped in any way. See you next week.